class, this is Dr. Selby here, and I just wanted to do an example of drawing a Lewis structure that has an expanded octet. Non-metal atoms that serve as a central atom in creating covalent bonds can expand their octets if they occur in periods 3 or greater, and this is because they can borrow from the d electrons. This commonly happens with phosphorus and sulfur. And so let's go through some examples. The steps to obtaining the Lewis structures are actually the same as the steps that we covered in this previous video of simple polyatomic molecules and ions. And so we're just going to count the total valence electrons, choose the center atom, connect surrounding atoms to the central atom with lines or bonds, then assign electrons to terminal atoms so they have a complete valence, and then if anything's left over after this step, it'll go on the center atom. Step 6 won't apply to these. So the examples we'll be doing today are phosphorus pentafluoride and sulfur tetrafluoride. So first step is to count the valence electrons. And we have 5 coming from phosphorus because it's in group 5A. And then each fluorine's in 7A, contributes 7, but we have 5 of them. And this equals 40 total. Sulfur is in group 6A, so it contributes 6. And then again, each fluorine, it's in 7A, contributes 7, but we have 4 of them. And this equals 34. Then we're going to choose the center atom. It's pretty obvious that phosphorus and sulfur are the center atoms in these cases, but just a side note is that fluorine can never, ever form more than one bond, so it can never be a center atom. Okay, so center atom is phosphorus, center atom is sulfur. Then we're going to draw in our terminal atoms, the fluorine atoms, on each and connect them with single bonds and subtract what we use. And so we have 5 here. Connect with single bonds. And then subtract what we use. So each bond or line represents 2 electrons. And so 2 times 5 is 10. So we're going to subtract 10. And that means that we have 30 left. We're just going to do the same thing over here for the sulfur and connect with single bonds. We made 4 bonds, so we used 8, so minus 8, we have 26 left. The next step is to put a complete valence on the terminal atoms or the fluorine atoms. Since each fluorine already sees 2, it needs 6 more or 3 lone pair. So we put 6 electrons, 3 lone pair, on 5 atoms, and so that equals 30. So we've used everything and we are done. Each fluorine has a complete octet, and phosphorus has 10 around it, but that's okay because it can expand its octet. So that is a valid Lewis structure. We're going to repeat the process for the sulfur tetrafluoride, and we're just going to put our valence electrons on the fluorine, like in the last example. Okay, so now each fluorine has 8 around it. We used 6 times 4 is 24, so we subtract that, 24, and look at this, we have 2 left. And those remaining 2 valence electrons go on the center atom. Minus 2 is 0. Now each fluorine sees 8 around it, sulfur sees 10 around it, but that's okay because it can expand its octet, and this is a valid Lewis structure. I hope this was helpful. Thank you. Have a great day.